Dear students, welcome to the mathematics class. Today I am going to discuss about three-dimensional geometry. So far we have studied vector algebra. Now the next chapter is three-dimensional geometry. Three-dimensional geometry is a continuation of the chapter what we have studied in your 11th class. So you have already studied the basic concepts of three-dimensional geometry. So now we will continue with more concepts. In this chapter we are going to study the equations of various type of lines, planes, angle between two lines, angle between two planes, angle between a line and plane, etc. So we start with the very important concept that is called the direction cosines and the direction ratios of a line. In 11th class two-dimensional geometry, you have studied various type of equations of a line. In all those equations, there was a very important concept involved that is called the slope of a line. So when we discuss a line in two-dimensional case, the slope is very important. Now, when we extend the study to the three-dimensional space, what will be the equivalent concept in the three-dimensional geometry? That means what is the equivalent concept of slope in the three-dimensional geometry? The answer for the question is the direction cosines of a line. So consider a three-dimensional space and suppose a line, there is a line and that line make some angle with the positive x-axis, y-axis and z-axis. Okay, suppose alpha be the angle made by the line with the x-axis, positive x-axis, and beta be the angle made by the line with the positive y-axis, and gamma be the angle made by the line with the z-axis. Then these three angles will determine the direction of the line. So these three angles are called the direction angles of the line. Then if we take cosine of these three angles, to convert into the real numbers, we will apply the cosine. So cos alpha, cos beta, cos gamma will give three real numbers. So these three real numbers will give the direction of that particular line. So these three numbers are called the direction cosines of the line. So that means cos alpha, cos beta, cos gamma are called the direction cosines, and these three values are denoted by L, M and N. That is L equal to cos alpha, M equal to cos beta and N equal to cos gamma. Okay. So these three real numbers will give the direction of that particular line, and very easily we can prove that L square plus M square plus N square always equal to 1. L square plus M square plus N square always equal to 1. Yeah, in another way what we can say, L I cap plus M j cap plus N k cap will be always a unit vector along this line. So very simple language, what is meant by the direction cosines means, if you take a unit vector along this line, then the components of that particular unit vector will be the direction cosines of that line. Now what is meant by the direction ratios of the line? if we multiply these three real numbers by a real number, yeah, any proportional values of these three real numbers are called the direction ratios of the line. Okay, in another way, if you multiply a unit vector by a scalar, what happens? You will get a vector in the same direction. Okay, you multiply by a positive number, you will get a vector in the same direction, and the components of that vector will be the direction ratios of that line. So direction ratios are always proportional to the direction cosines. So in the figure, you can see a vector directed from O to the point G. So the coordinates of the point G are minus 2.5, minus 0.5 or 0.3. So these three numbers represent the direction ratios of that line. And if we divide by the modulus of that vector, then you will get a unit vector along the line, and that will be the corresponding the components of that vector, unit vector, will be the direction cosines of the line. So geometrically, that is the meaning of the direction cosines and direction ratios. The direction of a line is determined by a unit vector. A unit vector is enough to determine the direction of a vector. So the components of that unit vector will be the direction cosines, and if you multiply this vector by a scalar, then you will get vectors on the same direction with different magnitudes. That means these the components of these vectors represent the direction ratios of that line.